Hello, everyone. Welcome to Beyond FinOps podcast. My name is Eli Mansour, and in this podcast, we'll go through FinOps related topics. Those can be operational topics related to what should I do in order to implement the FinOps culture within an organization, but it can also be um, episodes related to technical topics, always with a hope and the desire and the objective for us to be able to save on our cloud spend. In this session today, we'll speak about Amazon EBS. Yeah, it's a topic that most of us have heard before about already, but because AWS made some changes to the EBS volume specifications recently, and because there were some announcements related to EBS in the past few months, I think it's a good opportunity for us to kind of review the nuances related to EBS and to speak about the pricing model, make sure we know which volume is the right fit for our needs, and hopefully we'll be able to save some dollars out of this session. In preparation of this session, I also asked some statistics about EBS utilization from my friends in Datafy, and we'll look into that later on, and also we'll speak about the Datafy disk right-sizing automation capabilities in later stages of this episode. So before we drill down to EBS, let's look at Amazon storage services. Yeah, as always, Amazon gives us various options like the building blocks to build our application. And we see that we have S3, which is Amazon Object Storage Service. We see EBS is our object store. File systems, a variety of those with Amazon EFS, FSX, and Lustre, and some backup services. The topic for our episode today is Amazon EBS. So what is Amazon EBS? Amazon EBS is an easy to use, secure, high performance block storage service designed for use with EC2 for both throughput and transaction incentive workloads at any scale. Yeah, that's the definition. And in reality, if we want to make it simple, so it's actually the USB drive, the disk on key that we attach to our EC2 instances. Now, there are various types of EBS volumes. We have two categories: SSD backed volumes and HDD backed volumes. SSD are more transactional. Those are actually flash drives that are connected to our EC2 instances. Much better fit for I/O intensive workloads, read and write operations on the volumes. And HDD backed volumes are actually magnetic drives, the ones that we used to break when we were kids, but these are kind of mechanical disks that store our data. A much better fit for throughput dependent workloads and less for transactional workloads. In the SSD, we have various types, and we'll speak about those in more details in a second. We have general purpose 3, general purpose 2, IO1, IO2 block storage, and for HDD, we have the ST1 and SC1. In this episode, we'll focus on the SSD backed volumes, and now let's run a comparison across these options. We'll start with comparing GP2 to GP3. GP3 volumes are the latest generation of general purpose SSD volumes. They offer more predictable performance, scaling, and prices that are up to 20% lower than GP2 volumes. Let's translate that to make it simple. GP3 are later generation, they provide better performance, and they are lower in cost, 20% lower. So there is no reason on earth to use GP2 volumes. So we can make a conclusion that if you're using GP2 volumes, you can stop that, you can switch those to GP3 and nothing bad will happen. You'll just save some dollars. So when we compare GP2 to GP3, we have a winner. The winner is GP3, of course. When we compare IO2 to IO1, IO2 is here again, IO2 is the later generation that you should prefer versus IO1. We'll make it quick. Yeah, there is no reason to use IO1. If you are using such, let's switch to IO2, or let's wait a few steps in this episode. Maybe we can switch to GP3 based on the recent changes AWS made. But if you're using IO1, really there is no reason to do so. So now we are left with GP3 and IO2 as our options for SSD volumes, yeah? And we'll run a comparison across these two types of volumes, and we'll run the comparison as before and after September 25. So when we make the comparison, we'll actually compare the two drives in various criteria. Yeah, we have the volume size, we have the maximum IOPS, and we have the maximum throughput. And when we look at the disk size, the volume size, before September 25th, there was a big difference. There was also a big difference in the max IOPS and also a big difference in the max throughput. So actually, if you needed a volume larger than 16 terabyte, or if you needed IOPS larger than 16,000 or throughput larger than 1,000 megabit per second, you had no choice, you had to go with IO2. Now, what happened after September 25? AWS made some improvements to GP3 volumes. And let's see what these improvements are. So when it comes to volume size, hey, we can get up to 64 terabyte. So actually, there is no limitations from the disk size anymore. AWS also increased the maximum amount of IOPS for GP3. So it's no longer what it was. It's actually now 80,000, which is a large amount of IOPS. Yeah, there are only extreme use cases in which you need more than this. And also the throughput was increased to 2,000 megabits per second. So actually, great improvements on the GP3 side, and frankly, it should fit 95% of your use cases. Still, IO2 has its advantages when it comes to IOPS larger than IOPS, or if we need throughput larger than 2000, or if we need to attach an EBS volume to multi EC2 instances. IO2 is the only volume that has this capability of multi-attach. When it comes to the pricing, and when we compare the prices of GP3 to IO2, we should look at various price categories. Yeah, the price per gigabyte month, the price per IOPS, and the price per throughput. And we actually see the differences here on the slide. From price per gigabyte month, we see that IO2 is more expensive. When it comes to IOPS, we see that IO2 is much more expensive than GP3 volumes. And actually there is, in GP3 case, a cost for the throughput provisioned, but I would say the more meaningful items for us to look at are the provision, the gigabyte per month, and the IOPS. If we run the comparison, we see that the cost per gigabyte is 56% higher when it comes to IO2 versus GP3. IO2 is the more expensive. And when we compare the cost per IOPS, we also see that IO2 is more expensive, six times more or 13 times higher cost for IO2. So if there is no reason to use IO2, let's not use it and let's prefer GP3. When we summarize it and we want to get into conclusion, we started by eliminating the GP2 and IO1. We saw that earlier in the episode. And then we were left with two options, GP3 and IO2. And we saw that IO2 should be used only in, let's say, extreme or specific use cases where you need IOPS larger than what GP3 can provide you, or throughput or multi-attached capabilities. So actually it has a superior specifications, but are really used in extreme use cases. And for the majority of the use cases, you should go with GP3. Yeah, I would assume that 95% or even 100% of your use cases can be addressed and achieved by using GP3 volumes. Now let's look at EBS pricing model. You pay per what you provision. For every gigabyte per month, for every IOPS, for every throughput, you pay. So you really need to pay attention to how much of this you provision per each of your disks. EBS volumes are persistent. Yeah, they have its own life cycle. Even if they are not connected to any EC2 instance, even if they are connected to a stopped EC2 instance, they still exist. Yeah, remember the USB, the flash drive, they still exist and you need to pay for those. You can scale up an EBS volume. Yeah, you can increase the amount of gigabyte per month provisioned, but you cannot scale it down by using the AWS native tools. So if you don't have a specific tool that is specializing in downsizing EBS volumes, you won't be able to do so. But you can increase a disk size. So actually start small and grow as you need. And you should be familiar with delete on termination. Delete on termination is a checkbox that is configured when you spin EC2 instances. And this actually tells the AWS platform what to do with the disks, with the volume, once the EC2 instance is deleted. If the checkbox is checked, we will also delete the EBS volume attached to the EC2 instance once the EC2 instance is deleted. But if we uncheck this checkbox, the EBS volume will remain even if the EC2 instance was deleted. And as we saw earlier, you pay for volumes which are not attached to EC2 instances. So in this case, you will continue to pay for the volume. And from what I see when I support various organizations, I see tons of these volumes laying out there and cloud users are paying for it. When it comes to EBS utilization, how much of the gigabytes that we provisioned are actually used, here I have an interesting statistics from Datafy. So Datafy are providing unique capabilities for monitoring your EBS utilization, but they also bring you a unique capability of automatically right size the disk size, including the downsizing of it. So you can actually save tons of dollars when you downsize the disk size and so on. So in this statistics, in this graph, we actually see the disk utilization. The left side is showing us the amount of disks monitored that are underutilized, that are over provisioned. And we see that the majority of the disks are with 10 to 20% utilization. Think about it. You provisioned 100 gig volume and you only use 10 gig, 15 gig, 20 gig out of it. So we actually have a waste of 80 gig per month. Now, if you have thousands of those, and most likely you do have thousands of those, that's a lot of dollars that that can be considered as waste and that can be saved. On the right side is actually the disks that are highly utilized, and we see that it's really low percentage of the disks, really low amount of disks that are highly utilized. So not only that you pay for unattached disks, and most likely you have those, not only that you pay for disks that are attached to stopped EC2 instances, most likely you also overpay for the amount of gigabyte that are provisioned, because as we see from this graph, most of the volumes provisioned are over provisioned. So let's look at the techniques we have to optimize our EBS costs. So as we mentioned earlier, GP3 should be our default option. There is no reason to use GP2. There is no reason to use IO1. And we should use IO2 only in extreme use cases where we need higher IOPS than 80,000. We should remove unattached disks. We should remove disks that are attached to stopped instances. And we should right-size our disks configurations. The best thing is to start small and scale once needed, but as we understand, we cannot downsize an EBS volume, and for that we need some help from other tools such as Datafy that I mentioned. How do we analyze EBS cost? So I'm sure you are all familiar with AWS Cost Explorer. It's AWS native tools for cost observability. And if you want to filter and see the EBS costs, we should use the filters on the right side, and we should go to usage type group, select all the options with EBS. Yeah, you can just type EBS, you'll see the different options, and you can check the checkbox to see provisioned IOPS, IO2, GP2, GP3, IO1, and IO2. This will create a graph that's showing you the costs on a daily, monthly, or hourly basis. When you run the report, it's also important to filter out credit and refunds, so you will actually see the costs and the whole cost of your EBS volumes. Now, what do we see in this report? Actually, the majority of the volumes that are used are GP3. So great work, team. We do something great. We transitioned to GP3. Most of our volumes are using the right volume type. We do see some use of IO2 volumes, and we do see some use of GP2 volumes. What do we do about it? We go to the DevOps team and we ask, hey guys, why do we use IO2 volumes? Hey guys, do you know that GP3 volumes are 20% lower in cost versus GP2, you know? Have we considered upgrading to GP3 volumes? So this opens a discussion about what type of volumes are we using, and in most cases you will find out that GP3 can be the winner. Here in this case, we are dealing with AI team that actually have the requirements for IOPS, and this was the reason they are using IO2. But GP2 volumes, there is really no reason to use it. Another tool that you should be familiar, provided you free of charge by AWS, is AWS Cost Optimization Hub. It's a tool that AWS highly invests in these days, and actually there is a great team behind it to really understand the FinOps use cases and the FinOps needs. And in this tool, they actually provide us recommendations for optimizing our cloud spend and on saving dollars. In this example, I went to AWS Cost Optimization Hub, and in the top filters, I search for resource type equal EBS volume, and I also filtered for various recommended actions like right size, delete idle or unused resources, or stop idle or unused resources. And we can see a quite impressive list of volumes that can either being right sized, and here we have the recommendation. Yeah, hey, you provisioned 4,000 IOPS, you can be good with 3,000. Go and save $33 a month. And we can also see quite amount of volumes that do nothing. They sit there, we pay for them, and we don't get any value out of it. So this can be deleted. So we see this list, and we can actually delete these volumes. An impressive capability that was introduced to AWS Cost Optimization Hub is actually to run the delete action from a Cost Optimization Hub. It can actually take us to the screen that says, hey, if you don't want this volume, delete it and save the dollars. So great work, and looking forward to what's next with Cost Optimization Hub. I have great trust in the team. Okay, so now we know how to clean unused disks. We know that we need to shift to GP3 volumes. We know that we are paying for volumes that are attached to stopped instances, but we are left with a major cost driver for EBS, which is over provisioned. Yeah, we saw from the statistics presented earlier that most of the EBS volumes are over provisioned, and we cannot downsize a disk natively. We need someone to help us. And the someone to help us with these tasks, especially if we have thousands of disks and we are running large scale workload on the cloud, we need help. And here comes the Datafy tool. Yeah, Datafy will help you quantify the saving opportunity. This is one, but once you allow it to automate the disk size, you will be able to see how they automatically and magically downsize the disk size, save you dollars, and more importantly, they don't make a downtime. I hope this episode was beneficial for you. We went over the different EBS volumes out there. We spoke about what should be your preferred volume to use. We spoke about the pricing model and where are the, let's say, ways for you to generate waste, but also about the ways to remove this waste. And I hope this episode was informative and that will help you save some dollars. Please reach out with more topics you want me to cover. Please reach out if you want to participate in the next episode of the podcast, and looking forward to hear your feedback. My best regards to all the FinOps practitioners out there, and moving forward to record the next episode.